the Institute of Engineers Ireland. So I'll hand you over to Declan now.
Good afternoon, and to everyone online as well who's watching us today. I'm here today to talk about Part B, fire inspections and compliances, and in particular, obviously, from the role of a fire safety engineer on projects. As Richard said, I'm a fire safety engineer, 24 years experience. Current projects, which unfortunately the image didn't come through, is the National Children's Hospital. So I'm the resident fire safety engineer present in the National Children's Hospital. There we go, on cue. A little small up in Dublin, if you're aware of it, up there in St. James's Hospital. We've also been involved in two of the other projects. Connolly Satellite Centre, which was recently completed there a few years ago, and also the Tala Satellite Centre as well, which are there as part of sort of support in relation to the overall strategy for delivery of children's health services and things like that in Ireland. So what I would like to talk about first is maybe some of the key stages in the inspection process, particularly from the perspective of a fire safety engineer. First and probably foremost would obviously be a review of the fire safety certificate documentation that's been submitted, and in particular any conditions that were attached therein. Obviously, there's different degrees of fire engineering that can be done. So, for example, in the case of the Children's Hospital, I'm actually responsible for the inspectorate and compliance side, hence the reason why I was invited today to actually speak here today. However, we have a partnership with Michael Slattery's in relation to they are responsible for the design, but then equally in terms of my role, then I need to interrogate their design in order to see exactly what needs to be achieved, how are we achieving compliance, what is the compliance requirements, so that whenever I'm doing the inspections, etc., that I'm following through on all that. Secondly, then obviously we have to review the various fire safety installations that are going to be implemented on the project, and obviously identify some of the key elements that are going to be involved. So it's not just going to be things like fire-rated partitions, fire doors, glazing, fire alarm and your emergency lighting, dampers, etc. I mean, obviously in the case of the Children's Hospital, we have a multi-storey basement car park, so we've got complicated jet fan extraction systems. The hospital itself incorporates an atrium style design, so therefore we've got natural passive ventilation type systems in the building, and then we have a multitude obviously of firefighting lifts and facilities and sprinkler systems and things like that there, which may go over and above and beyond what you would have in your normal typical project and things like that. Third thing then obviously would be to review the building contractor's program, in particular to review sort of the key stages of the construction, and that would itself help us coordinate particular times, etc., and things like that to do our inspections. And taking all that kind of information together then helps us in the development of the preliminary inspection plan, or the PIP, as you're probably all well aware of, and that then assists us then throughout the rest of the program of the project time whenever we do our inspections and things like that there. I think as some of my other speakers have alluded to earlier on, obviously the code of practice for inspecting and certifying buildings is an invaluable tool in order to achieve that. So not only does it assist and give guidance on the inspection plans and the factors in determining the inspection plan, it also gives us, guidance in terms of the inspection and in particular the inspection frequency. I suppose the Children's Hospital is probably unique in a sense from a lot of other projects because I am actually a resident fire engineer, so our inspections are daily. We are there 5 days a week and doing obviously ongoing inspections throughout the whole build of the project because of the size and obviously the complexity of it. Similarly then obviously there's guidance there in respect to the inspection notification framework, the INF, and again even with the fact that we are a resident engineer, that we still need to obviously coordinate between ourselves and the contractor, etc., as to when things are going to be available and how for us to be able to sort of schedule our time, because equally obviously with a project of that size and everything else, we can't be everywhere at once, and obviously so being able to work in tandem with the contractor in particular and the other engineers and the architects on the project is key. Also, obviously, whenever we're doing our inspections and raising issues and things like that there, we have to bear in mind as well that there's going to be various follow-up procedures, particularly obviously to go back and potentially review issues to make sure that they've been addressed, and then obviously to resolve and close out issues as well. Probably going to be one of the things I'm going to be sort of stressing on, particularly from a sort of building control perspective from yourselves, is that obviously from our role on site is a lot of it is focused on not just identifying any of the issues, but the close out of the issues, and also the record keeping the same. There may also be obviously tests and things like that, which may be come about because of the nature of the project, in which case, again, at the very early stages of the project, it's important to actually identify where you may feel that there's a need for testing to be done, maybe to do with some complex systems or new types of systems and things like that that have been introduced on the project that may need obviously some form of testing or validation in order for certification to be achieved. And then finally, obviously, the records of inspection, which is critical. You know, the evidence that's there that we're conducting our inspections and we're conducting them to a relevant standard, to the point then obviously that you as a building control authority, etc., are confident in our abilities and confident in what we're doing, because obviously you talk about how you have a certain quota or percentage of things that you would inspect based on your risk. Obviously, whenever we're inspecting, we're trying to actually inspect as much as we can to make sure that we've got a very robust system and to make sure that we're delivering basically a fully compliant, fire safety compliant project. In order to be able to do the inspections, you got to have the tools. As I say, the iPad itself is a critical part now of any inspection process and any project, between both fire engineers and any other engineers on site. I think if you were to walk the Children's Hospital today, I think you're going to really see that nearly everybody there is walking around with an iPad, and that's the way it's gone. It's probably a complete about turn on the industry over the last number of years, in the sense that, you know, we carry our drawings, we carry, like, even if it's just mechanical, electrical, from the contractor, subcontractor's perspective, everything is now available to hand. If I'm going to look at fire stopping, I have the details with the fire stopping with me on the iPad, and I can refer to anything that I need to refer to when I'm there live in the field. There's none of this where you may have to go back and ask a question or ask a query. You're doing it sort of in real time and making sure that anything that you're doing is compliant. As well as cameras, which is probably the more traditional way of doing things. You can see there in the image there, we use GoPro cameras with extendable poles. I think Colin had said it earlier on in relation to consideration of health and safety and things like that and stuff. It's not always the case that you have to climb a ladder. In fact, if anything, the extension poles and everything else allow us to get into every little nook and cranny of the building, where the contractor's worst nightmare, because of the fact that we can see all and find all. Similarly, we also utilize scope cameras and various other things, obviously to make sure that whatever we're looking for, be it cavity barriers and walls, etc., that we can find them. And then obviously there's various gap measurement tools for things like measuring threshold gaps or gaps around doors, etc., and stuff like that there, which again is all part and parcel of the inspection process. But I suppose the key message there that we would be giving is, look, through the incorporation of current technologies and tools, it's possible for a building inspector like me to more readily inspect installations, and again, ensuring that there's a high level of compliance being delivered on a project. The key stage on a project is sort of broken out there into 5 headings. The first one for us would be wall closures. This is where we'll be getting our notifications that the walls, for example, would be boarded on one side. Services may be installed. Letterboxes, and particularly in the way we had done it in the Children's Hospital is, for example, high-level services such as dampers and things like that would have been installed to a part. So it allows us a good opportunity to get in and inspect the formations, inspect the partitions, and ensure that those are being formed in accordance with the manufacturer's recommendations. Things like deflection heads and things like that have all been properly done and addressed, particularly on the fire-resisting wall elements. Our next stage then is ceiling closures, kind of self-explanatory, but again, It's like a last opportunity really to get a good look at all the fire stopping, the above ceiling services. So for example, ceiling void detection and things like that. In particular, the Children's Hospital, we have ceiling void sprinkler coverage, etc., and everything. So again, getting the notifications at these stages allows us the opportunity then to get a full examination of those before they're closed. The room or the room completion stage, again, there is still some element of above ceiling in that, and there always is throughout, I suppose, all the remaining stages, because obviously if the tiles are up or if the tiles are off and access is there, we would still always have to be able to go back in and have a look above the ceiling at any point. But at the room completion then, the focus drifts down to the lower level. We're looking at then the general fire alarm in the room, the emergency lighting in the room, signages, etc., and particularly fire doors, fire glazing, anything like that, installations, and reviewing all those, again, to ensure that there's a high level of compliances. Commissioning, again, fairly self-explanatory. We've got to make sure that all those active systems that we put into the building actually work. And there's a very, very strict sort of regime in relation to doing all the validation of all the active fire safety systems in the building. And again, at that stage, whenever we get to commissioning, obviously we're into reviewing of all the certification documents and things like that, again, to make sure that both we're satisfied that all the certification that's in place, and equally that we're happy then to accept the certification that may be issued by the relevant subcontractors and things like that, which again is kind of very critical whenever we're delivering any kind of project. The final stage there is, as I say, the handover stage. Within the handover stage then, again, obviously we're into the final documentation review, but probably more high level of documentation review then as well, particularly the contractors and the subcontractors, BCAR certs, final closeout of all our snags, etc. And then also all that has to be obviously undertaken before we as a fire engineer can actually give our certification or our ancillary certification in relation to compliance. Just to sort of walk you through a process, I think a few of you, and I think Conwell had explained, mentioned his OB system. We incorporate a couple of systems that we use. This was probably maybe more of a standard system that we use, which is the SiteWorks system. Maybe some of you are familiar with it and things like that. But basically, this is just basically an extract of one inspection report, and this is one type of inspection. The color coding, etc., represents various issues and items that we've identified. Some of them may be fire stopping issues. Some of them may be issues with fire doors. It may be issues with a fire damper. It could be an issue with a partition. There's any number of things that get raised, particularly during the course of an inspection process. I've focused in there on a pin 41, just to give you an example. As I say, the issue that was there is that was a fire stopping issue and everything else. So that was identified. A description was provided, details were provided. There's also photographs provided. So as you can see there in this particular one here, damage was done to the fire stopping, etc., and the damper. Something that usually happens when ductwork gets installed after the damper's been installed. So as it's done as a stage process, the damper in this instance was installed and fire stopped, but then the subsequent installation of ductwork then after damaged the fire stopping. And again, we've go through in our inspections, we've identified it with our GoPro camera, we've identified it to the contractor, and then they go back and do a remediation of it. All this information then obviously is actually transferred to the contractor, and that allows them then to take remedial actions. We use that probably about 95% of the time on a lot of our standard projects. Now in the case of, say, something that's like the Children's Hospital, we use BIM 360. I'm sure a lot of people are familiar with BIM and the BIM platforms and various things like that, and with BIM 360. But again, this is a similar mechanism to doing that, albeit that, again, whenever we are working on it, what we do is when we raise this issue, this is actually a contractor-led platform. So whenever I go through and do my inspection and I raise an item or an issue, that goes directly then to the contractor. The contractor's getting it live in real time once we sync our iPads. And then in relation to that, once we show what the issue is, again, we can do a similar exercise in pinning it. So we've identified the location to them. Again, we can also then again identify what the defect is. There was damage and fire stopping in this case. And then what will generally happen then is the contractor will take that information. He will then delegate it to the relevant subcontractor. that relevant subcontractor then takes it and obviously actions the remediation. And then during the action, for example, we've identified there where the damage is. They've come back then with corresponding supplementary evidence, then photographic, to show that the remediation has taken place. We then subsequently go through that and review it, and we close it out. And then from your perspective, particularly from a building control perspective, this is how we achieve circular closeout of issues. And for everything that goes up, it has to come down, or the issue has to be closed out to the point that obviously whenever we get to the end of the project and get to the completion of the project, we should have zero snags. One of the that needs to be done on any project, but particularly obviously a project of such complexity as the Children's Hospital, would be benchmarks. I can't stress enough the importance of things like benchmarks, or first of a kinds as they're called. That's just an example of one that we did there for underfloor fire barriers. That one's actually fairly live. That was only done last week. But in relation to where it is so invaluable is it gives the contractor the opportunity to both take a product or take a system and things like that. Again, for them to review it with the relevant subcontractors so that they get a good knowledge of what they're supposed to be doing and how it's supposed to be done. Getting all the relevant details and information that's as part of that. It's actually put together into a document that's kept as part of the record. And correspondingly then, as the fire engineer, we attend the site and we review the installation. We obviously issue feedback and things like that, and if there is any issues with it, then potentially we may actually be raising BIM issues on the installation, or what generally happens is we give it a status A, which is it's fully approved, B, it's approved with comments or requirements, and status C where it's rejected. And then what happens then obviously is there's a record taken of that. As the consultant or as the engineer, we would then keep a formal record of the fact that whether this system is then being approved, and then obviously where that then is rolled out or implemented elsewhere in the project, it would be expected then that it follows the benchmark. And then whenever we do our inspections at a later stage, we're evaluating and assessing it against that benchmark that we've set out. As I say, I cannot stress the importance of those in projects, particularly ones of large complexity, because, for example, in this case, this may be done maybe 20, 30 times, but whenever you do benchmarks, say, for example, in fire dampers, I think we're well up into the region of something like 6,000 in the Children's Hospital. You know, when we do a benchmark on fire doors, I'm at 10,000. I think we measure walls in kilometers. That's the size of the thing. So, like, when you're getting things of that magnitude, we kind of want to get them right first time. And we wouldn't want to be doing, as Conal had said, and tearing down a wall or tearing down a bit of partition because it wasn't done right. I mean, we got to get it right first time. And benchmarks is the key. As well as the benchmarks, you got to know the products. That's probably one of the biggest challenges as well, in terms of what is actually being installed on site, and particularly for any of the, well, for both the contractors team and obviously for the fire engineer and the design team in general, is to know the products that are being used and know them. And again, we can learn about them through the benchmark processes. Obviously, we'd be familiar with a lot of them ourselves from our own experience and things like that there, particularly the likes of the fire stopping products and details like that. The typical details for the installation of fire dampers, typical details for the installated fire-related ductwork. That's a very specialist one there for fire stopping detailing in relation to buzz bars, electrical buzz bars, which again, there's very, very few manufacturers or products that actually can deal with that and fire stop it properly. So again, you know, it's a unique kind of one, and we know that because when we went looking for it, we couldn't find it. And we had to, you know, scour Europe and find a German manufacturer of a fire stopping product that actually had the relevant details that could give us our 90 minutes and our 2-hour fire resistances that we needed on these things. Because again, as the inspector, I need to know that whenever someone's installing anything, that they're installing it right, they're doing it as per the manufacturer's details. And that involves obviously a lot of research and a lot of checking of a lot of the documentation and everything else. All this is happening in the background before obviously yourselves, maybe as building control inspectors as well, are coming to site and looking at this. I mean, it's for us to sort of learn everything and know everything as such, as insofar as possible. And as I say, tablets themselves are a wealth, because obviously I can't know everything, but I can carry it around with me. So anytime I look at anything when I'm on site, I can compare it against whatever I see in the manufacturer's installation standards. And it's also very important to engage with the product system manufacturers, particularly where there's any kind of deviations maybe that might arise. And consultation with the manufacturers is key, because in some instances, it's not a case that necessarily everything that has to get tested again or anything like that. A lot of the time, you can actually just work with your manufacturers and work with the systems that they have and find ways of getting things obviously compliant without the need to sort of have these exceptions or deviations or bespoke detailing and things like that. So all the while we're doing all this and everything else, and the building is growing and changing, et cetera, we do have to then take obviously stock and look at the fact that, okay, when we started out, I got my drawings on my iPad and everything else, which was based on the original fire cert, and I'm walking around the building, and all of a sudden something's changed. So then my role then obviously is to look at that and examine what those changes are, identify what those changes are, because at some point then in the project, there may be a need then to go back in with a revised fire safety certificate application. And obviously in the case of the Children's Hospital, that's ongoing and actually being actioned now at present. Again, from a consultant's or a fire engineer's perspective, the timing of that obviously is critical, because if I go too soon, I could have other changes, in which case I'm going back to do another revised fire safety certificate application. But equally, if I do it too late, and then also waiting for the fact that I'm trying to get a fire safety certificate to grant in time so that I can certify a building. So again, the timing of that is critical. When looking at the project as a whole, there may be obviously needs for site-specific fire testing. And again, it's very much dependent on the project, but for example, we may have very large, complex, and detailed service arrangements, which may require fire stopping. And in case of some of them, they go above and beyond what the manufacturer's requirements are. And therefore, for example, if I have a 450 mil diameter pipe, it's not in any standard fire stopping brochure as to how that can be achieved. So therefore, we may need to go back and actually get something fire tested in order to be able to demonstrate compliance. Similarly, the project may have curtain walling in it, and obviously if it does, there's relevant standards then obviously the EN 364, etc. Or in the case of the Children's Hospital, we've obviously got cladding systems there, and we actually have them in both masonry and SFS systems. So therefore, we've got multiple tests done on the facade system that's been used. Again, one of the other things that we have done in the project is we have very complex partition constructions. And as part of that, there's been separate testing done with Gyprock in relation to updated fire testing of their wall systems based on actual wall constructions and assemblies that's been used in the Children's Hospital. Some of the more recent testing that they've done actually incorporates that, and even advise on that now, etc., on the back of what the testing that they've done in the case of the Children's Hospital project. It is, as I say, very important that any site variations are identified early, that the testing, if required, is conducted as soon as possible, obviously, because getting testing done with any of the sort of recognized test houses, such as the likes of your Effectuses or your Warringtons, etc., that can take 6 to 9 months, and particularly on the time frames of projects and things like that, that's time that's probably not available in a lot of projects. So if you need to get something done, it needs to be identified early, and it needs to actually be actioned early. I mean, I don't know what anyone else's experiences in the room here is, but what we have found in the past is it's even getting an appointment with them can take a matter of months, let alone getting the tests and everything else instigated. And therefore, it can become a real risk factor in a project, particularly because you are assuming that whatever you're building is going to comply, but then equally you could get a test and have a fail, in which case you've got to go and do the whole thing again. In which case that becomes a serious risk, especially if you build something that you cannot demonstrate compliance to. Now, as I said, I may be say, the Children's Hospital doing a lot of stuff, but then equally that doesn't necessarily mean that I'm constantly going to be on site. There's going to be times whenever, particularly during some of the projects, that we are going to have to go to factories and things like that there. And as part and parcel of our role as an inspectorate and everything else, we may need to actually go to site and go to the factories where things are being manufactured and actually examine how they're being done. In this case here, that's an extract from a report that we did in relation to in relation to a healthcare project, in which case the rooms were actually being manufactured as partition rooms with walls and floors, and they were coming to site almost to that 90% assembly. But obviously, I can't inspect it if they're building it in a factory or in the factory and just bringing them to site. So of course, I have to go to the factory, and then equally that gives me the opportunity to review their QA, review their systems that they have in place as well, their check-off sheets, etc. And again, in the case of this project here, a lot of that is actually digital and online as well. So similarly to the way we would use our SiteWorks platform, they have a similar type platform where there's checks and balances done. I mean, I can see the reviewed fixings in the partitions and who signed it off before, etc. in their process. And again, it's having that sort of level of checks and balances that's being done, particularly by the engineers that are involved in the project, that gives you as a building control, authority, etc., some kind of comfort to know that, obviously that if I can do my job right, then it makes your job an awful lot easier. Similarly, the one on the right-hand side there, intumescence steel, obviously, or intumescence being applied to steels in relation to stairs, etc., that are constructed in the Children's Hospital. The steel in question there is actually being done in Holland. So therefore, before the stuff actually comes to site, we've gone to Holland and we've gone and sampled their systems. We've gone and checked, their record keeping. We've gone and checked their DFTs. We've checked their alcometers that they use. We checked the number of alcometers they use and which one that they used it and which steel. And we go through all that process and make sure that everything that they've done is valid and correct before it comes to site, and make sure that all those processes are done so that whenever they actually do arrive on site and are being assembled, that we have got a high degree of confidence that what we're delivering here is a compliant arrangement. And again, probably something you would like to hear from me is that engagement with building control is key, because obviously in various projects that we do, particularly, as I say, we would have a very high degree of inspection and engagement with building control in relation to the Children's Hospital, particularly in relation to fire. And obviously we've had multiple inspections and visits, all of which we've been a part of. And obviously we've had our various Section 11 compliance requests and things like that. But again, the key again is to engage with them, to respond to them and things like that, and to engage well with building control, because at the end of the day, when we demonstrate that we can respond to everything that's there, that gives you sort of the confidence that you're dealing with competent designers, that you're dealing with competent contractors, you're dealing with competent installers. And I think the key, I think even was stressed earlier on, it's competency here. It's probably one of the key things that comes out from everybody that's involved in the whole construction process. And then also, obviously, the last and probably big final stage is the certification process. As I said, there are questions that we need to consider, obviously, from the start, but this way actually may sort of organically develop throughout the course of the project, is how we're going to get it certified. I mean, the original intent of the project may have said that we wanted to deliver this as one project at the start, but obviously due to maybe the size and the complexity of it, or to do with the timing or whatever else, the project may need to be phased. And then obviously if that's going to happen, we're going to have to review then how we can deliver the certification for the project. Preparation of advanced notification of our certification is key. So then as part of that, we would have send our schedules to the contractors from the minute that we're engaged on the project, so they're fully aware of all the certification requirements that were going to be required. Issuing, as I say, of B-card deliverable schedules is key, because then that gives the contractor advance notice of all the elements of the constructions that we are going to look for B-card certification for, who they're going to come from, etc. And then as part of that, then obviously that's going to aid us in the completion of the project, obviously, because if they've got enough advance notice of what we're going to require, they should be able to get that to us in a timely manner so that we can do our review and obviously then sort of accept it, and then obviously be in a position as ancillary certifiers to give our own opinions of compliance, or our own certificates of compliance, and then equally for an assigned certifier to be able to issue their certificate of completion, etc. And obviously, as part and parcel of that project process, there's going to be other statutory certification that's going to be required. So, for example, obviously the standard ones would be fire alarm, emergency lighting, extinguishers, etc. So all that stuff, there's going to be sub-layers of certification that all has to be reviewed as part of the whole process and everything else, in order for us to be able to deliver a compliant building as such. I suppose that my final point on this obviously would be is the thorough checking of all the documentation that's issued. And that's probably sort of a big part of this process. The better that we do that at that stage will obviously ensure that that there would be no hiccups and such in being able to delay, or any delays in delivering the project at the end. Because obviously when we submit everything and it goes through the relevant building control reviews, etc., it probably helps that I keep the address consistent on the project, and maybe the names and descriptions of the project consistent, that I clearly identify what the phases are in the project, or things like that. And equally that, simple things as signatures or roles and things like that, that everything else is, easy to identify as well. So in order to make the whole process a lot more smooth and palatable. Okay, thank you all for your attention. And as I say, I hope you get a bit of an understanding of the role.